we know that this is 360. So it's 60 degrees shy of 360. So this angle is 5 pi over 3. We have to determine the reference angle. What is the reference angle?
60.
Yes, indeed, pi over 3. Perfect. So now we're asked to find, so I'm going to form a right triangle in which this piece will be its cosine and this piece will be its sine. Cosine of 5 pi over 3 and this piece will be sine 5 pi over 3. So let's determine sine 5 pi over 3 and you'll tell me the sine of sine and cosine 5 pi over 3, and we do not have to determine or look at a table or create a table for the rest. It's going to be very easy after we find sine and cosine. So what do you think about this piece is sine, so will it be positive or negative? Negative. So the answer will be negative. And negative sine pi over 3. Negative sine of the reference angle. The same thing here, but positive cosine of the reference angle. That's why I was saying from the very beginning, the reference angle dictates. Every time I need to determine, let's say, sine or cosine of 5 pi over 3, everything depends on the reference angle. If the angle ends in the third quadrant, then the reference angle, like this case, it's pi over 3, but sine will be negative and cosine will be positive. But we know this, and we know this. What are they? Yes, this is the square root of 3 over 2, and this is positive 1/2. I don't need to look anywhere else. I can immediately determine tangent of 5 pi over 3, cotangent of 5 pi over 3, secant of 5 pi over 3, and cosecant of 5 pi over 3. You don't need any table. Tangent is this number over this number. Very good. Negative the square root of 3. Awesome. Cotangent is the multiplicative inverse of this, which will be negative 1 over the square root of 3, but we need to rationalize into negative the square root of 3 over 3. Secant is 1 over cosine, no problem. And cosecant is 1 over sine. So this is negative 2 over the square root of 3, and we need to rationalize. It's useless to just sit there and memorize the rest of the table. There is no need. Once you know sine and cosine, that's all you need. And of course, these. And we're going to talk about these. We have not put these in the table, but these are very easy. We're going to get to that in a minute. But I need to look at a few examples with solving right triangles. And then we'll get to that. Okay, here we're asked for the following exercises, use a calculator to find the length of each side to 4 decimal places. So let's choose a problem. Of course, we can choose here, find x. Maybe that's more exciting. Or we can look at this and find x. Okay, so let's choose a problem. And these problems are on page 602. No preference? Okay, so let's start with 35. In that case, $35 on 602. I can go back. You want me to go back?
Just to the tangent, cotangent, secant.
Yes, of course.
Should you put this on?
So in 35, we are given a right triangle, and we're asked to find the sides of the triangle and an angle. Is that okay?
Yeah.
So we are given beta at the top, 12, 10 degrees, 90 degrees, A and B. For the following exercise, you used to calculate to find the length of each side to 4 decimal places. Okay. Well, first of all, we know that if this is 10 degrees and this is 90 degrees, we know beta immediately, which is
80.
Very good. Okay. Then let's suppose we continue with cosine of 10 degrees. Cosine 10 is B divided by 12. Cosine 10 degrees is the adjacent divided by the hypotenuse. And from here, cross multiply, B equals 12 times cosine 10 degrees. Here it is. 12. Make sure that the mode is in degrees before you put in degrees in a calculator. So we have 12 multiplied by cosine 10 degrees. So we got the adjacent leg, that is 11 point, they want 4 decimal digits. Okay, fine. So B equals 11.8177. And now it's up to you how you determine the other leg. It doesn't matter, you can use the Pythagorean theorem, but I would have preferred, for example, to use either sine 10. Sine 10 degrees equals A over 12. Sine 10 degrees equals A over 12. Cross multiply again, and I get 12 sine 10 degrees. I think that's much easier than using the Pythagorean theorem. So I have 12, and this time sine 10. And I get 2 points, so A equals, approximately of course, 2.0838. Questions? Okay, let's find the length x. Well, let's look at, doesn't matter, 42 or 43? 42 it is. So in 42, same page, 602, we're given this picture. This is 82. This is 39 degrees. This is 63 degrees. And they're asking us to find x. So the height of this triangle is 82. The two angles at the base are given 63 and 39. And they want us to determine the length, the base of this big triangle. Any suggestions from me? Would you like to suggest anything? Well, what I would like to do is denote this piece by A and this piece by B, and then obviously x is the same with A plus B. Is there a way of determining this piece? Yes, because these two are right triangles, and the opposite over the adjacent is one function, a trig function. The same thing for 39 degrees. Opposite over the adjacent is another trig function. Which trig function is that? Opposite over the adjacent. Tangent. Tangent, right? So tangent 63 degrees is 82 divided by A. Also, tangent 39 degrees is 82 divided by B. So one more time, let's do this together. So for 63, the opposite over the adjacent is tangent. The same thing with 39, opposite over the adjacent is tangent. This can be easily determined. All I have to do is just swap these two or cross multiply. So in a proportion, we can swap. And this is a proportion. So, or cross multiply. Let's cross multiply so I don't confuse you. So A tangent 63 equals 82, or A equals 82 over tangent 63. The same thing with B equals 82 over tangent 39. Once we determine A and B, we can get X. But I'd rather put it in one step in the calculator as 82 divided by tangent 63 plus 82 divided by tangent 39. Let's stop for a moment. Any questions on this? Is this okay? Do we understand this? Okay, are you okay? So I'll put it in one step. So 82 divided by tangent 63, and then plus 82 divided by tangent 39. And press enter. And the answer is X is approximately 143.04. We were asked, yes. We were asked here in this problem 42, we're given all this information, we were asked to find, if you want, the base of the leg. I cannot say it's a hypotenuse because I don't know if this is 90 degrees. I have to calculate. So for now, it's just the base of the triangle. I know we have 3 more minutes left, so let's just look at a very simple problem, like 23. So 23 on 601, we are given 10, 8, and angle A. And it only says evaluate each trig function of angle A. And I just picked 23, which is sine A. But we can determine another. So sine A will be, I'm going to call this C. I can calculate it, right? It's C is the square root of 100 plus 64. So this is the square root of 164. So sine A is the opposite over 100, square root of 164. What about cosine? 8 over, yes, we should have rationalized the square root of 164. What about a tangent? 10 over 8, which is 5/4. What about cotangent? Very good, 4 over 5. What about secant? I'm sorry. Yes, the square root of 164 over 8. And cosecant A is the square root of 164 divided by 10. Any questions?